Hello everyone and welcome to this video. Today we want to discuss about how we can find adjoint and inverse of a square matrix whose order is more than 3 or 3. Because for order 2 we already have done a video. If you want to see for order 2 you can check the video, it's already done. It will be available in the playlist. Today we want to talk about finding inverse of a matrix, square matrix with order 3 or more than 3. As we discussed before, what's the inverse formula? A inverse is adjoint of A over A mod. So to find the inverse we have to find the adjoint and the determinant of A. Let's take a 3 by 3 matrix. How we can find these things now? We have a 3 by 3 matrix which is A11, A12, A13, A21, A22, A23, A31, A32 and A33. These numbers just represent the row number and the column number, like A23 second row third column, A31 third row first column. First, to find the inverse you have to find the cofactors. The cofactors of this A matrix will be A11, A12, A13, A21, A22, A23, A31, A32 and A33. We have discussed how we can find the cofactors in the last video of determinants. You can check that, but to make a shortcut here, we have it cofactor formula is -1 power I plus j aij multiplied with the minor mij. And how to find mij? We remove the ith row and the jth column. Like for example, we want to find a1 2, replaced I with 1 and j with 2, we get here -1 1 plus 2 into m12 and -1 cube into m12 -1 into m12. And when we want to find m12 means minor of an element with removing first row and second column, because this first number represents row and the second number represents column. So we remove the first row and second column from this. We are left with a21, a23, a31, a33. Not from this is a cofactor one from the matrix itself. This is already calculated. So we have -1 into a21, a23, a31, a33. We will solve a question in the end. If you have any doubts in this, this is just a revision from the how to find cofactors. So we have the cofactor set. To find adjoint we need this cofactor set, because without this cofactor set we cannot find the adjoint. So what will be the adjoint of A for this? Just replace rows with column and column with rows, like we used in transpose. Like this is a11, a21, a31. This is the first column. Write it in row format. So we will have a11, a21, a31. This is the second column. We'll take this column and write it in row format. It will be a12, a22 and a32. Now take the third one and write it in row format. a13, a23, a33. This is the adjoint. To find adjoint we need cofactors. This is the how you find adjoint. Then you have to put it in the formula, which is A inverse is equals to adjoint of A over A mod, and we get the inverse. Okay, now let us solve a question. Let's take an example and implement these concepts. We have a matrix A, which is a 3 by 3 matrix, which is 1 0 2. Here it is 0 2 1. We have 1 minus 1 and 1, 1 minus 1 and 1. Now we want to find what? We want to find the A inverse of this matrix. We know the formula of inverse. A inverse A is adjoint of A over A mod. Now to find this adjoint of A, we need cofactors. We have to find all the cofactors. So what will be the cofactor set? Cofactor set. The cofactor set is going to be like something like this: A11, A12, A13, A21, A22, A23, A31, A32 and A33. We want to find this one. So in this question we have to find 9 cofactors. Okay, let us start. With A11, it's minus 1. First let me write the formula so that if you have any doubts it will be clear. The general formula of cofactor is Aij minus 1 I plus j into mij. Now let's find out all of them. Let's start with A11, minus 1 power 1 plus 1, because it's ij is 1 1 into m11. Let's say what is m11 now. You remove the first row and the first column. When you will remove the first row and the first column, it means this is gone and this one is gone. So what's left? We are left with 2 1 minus 1 and 1. These 4 will be left, right? So let me clear it because we need this set. So we have 2 1 minus 1 and 1, because we removed this first column and first row because it's A11. So we are left with what? 2 1s are 1, sorry, 2 1s are 2, minus minus plus 1, so 2 minus minus 1, which is 3. There is a minus 1 square, so minus 1 square is positive 1, so we get here a 3. Now let's go with A12. Similar way we will calculate all of them. Minus 1 cube into m12. Now for m12 we have to take out the first row and the second column to find minor m12. We are left with what? 0 1 1 1, right? 0 1 1 and 1, and we take out the first row and the second column. We are left with 0 1 1 and 1. We solve it. 0 1s are 0 and minus 1, 0 minus 1, it is minus 1, but there is a minus 1 cube, so this is minus 1 into minus 1, which is 1. So we got A12, which is 1. Now let us calculate A13. A13 will be minus 1 into 1 plus 3 into m13. So it's minus 1 power 4, so it will be positive. So m13 means you have to take out the first row and the third column. We take it out. What's left? 0 2 1 minus 1, right? These 4 are left. We have 0 2 1 and minus 1. We solve it. 0 minus 1s are 0 and minus 1 times 2 minus 2, so we have minus 2. This is cofactor A13. Let's continue and find the remaining all in the same way. To cap space, I will for the time being I want to delete this so that we have some space finding the rest using the same set and the same page. Now A21, it will be minus 1 cube into m21. So M21 means you have to remove the second row and the first column. When we remove the second row and first column, we are left with 0, 2, minus 1 and 1. 0, 2, minus 1 and 1. Let's copy it. 0, 2, minus 1 and 1. Solve it. 0 ones are 0 and minus 1 into 2 is minus 2, but the 0 minus minus 2 will make it what? Positive, so we have a 2. Right? We just solve it the product of the diagonals. 0 ones are 0, minus from the formula, minus 2, it's 2, but here it is minus 1 cube. So the answer will be minus 1 into 2, and we get a negative 2. This is A21. Following the same steps, we have to find all the 9 cofactors. Let's go with A22 now. It's minus 1 power 4. 22 means remove the second row and the second column. Right? We are left with 1, 2, 1, 1. The remaining one. 1, 2, 1, 1. 1 ones are 1. Minus 2, we have minus 1. This is power, even power, so answer will be positive. So answer is minus 1. Now let us find A23. Minus 1 power 5, because 2 plus 3 is 5. So whatever the minor will come, you have to times it by negative 1, 2 and 3. Remove the second row and the third column. We have 1, 0, 1, minus 1. Right? Yeah, 1, 0, 1, minus 1. Solve it. It will be 1 into minus 1 plus 0, but because it's a odd power, so minus 1 into minus 1 will become 1. Right? Now let me have some space here. I will like to erase this so that we can solve for the third row. We are just left with 3 more cofactors and we are done with the cofactor part. This is a little long step of the question, but we have to do it. A31 minus 1, 3 plus 1 into M31. Oh, I forgot to do this. Now I have to write it again. Just a minute, I will change it. We had 1, 0, 2 and 0, 2, 1, 1 minus 1 and 1. So A31. When we say A31, so we have to take minor M31, which is third row and the first column. When we remove it, we are left with 0, 2, 2, 1. So we have 0, 2, 2 and 1. 0 ones are 0, minus 4, but it's even power, so A31 will be minus 4. Because it's minus 1 power 4, it will be 1, so it will not make any difference. You have minus 4. A32 minus 1 power 5 into M32, which means you have to remove the third row and the second column. So 1, 2, 0 and 1. We are left with 1, 2, 0, 1. 1 ones are 1 and 0 into 2 is 0, so 1, but here it's minus 1 power 5, so minus 1 into 1, it will be minus 1. Now we are with the last one, A33. It's minus 1 power 6 into M33. So third row and third column gone. We are left with 1, 0, 0, 2. 1, 0, 0, 2. 1 2s are 2. It's even power, so the answer will be 2. So we got all the cofactors. When we have all the cofactors, we can write them. To avoid mistake, it's always better to do this step. Don't do directly in exam, because in exam there is a lot of pressure. There is a chance of mistake where it's Aij, and this matrix is 3 cross 3. This is the matrix of cofactors. We have A11, A12. One extra step can save a lot of time. A21, A22, A23, because when you are solving it on a paper, it's going to be some calculations, you are spending time on it. You can do it on rough paper, or if the examiner is asking for steps, you have to show it. Now put the values respectively which you calculated. Right, we calculated A11 to be 3. You can check if you are trying 3 1 minus 2, this one is minus 2, this one minus 1 1 minus 4 minus 1 and 2. This is the set of cofactors. We calculated all the 9 cofactors. Now to find adjoint, we have to replace rows with column and column with rows. Now adjoint of A, take the first column and make it the row. This is column, right? This is column, and make it a row. So it will be 3 minus 2 minus 4. Now take the second one, second column, and make it the row. It will be 1 minus 1 minus 1. Now take the third one and make it the row. When you will make it the row, it will be minus 2 1 and 2. So this is the adjoint. We have the adjoint. Now for this question, finding the mod is easy. Why it's easy? Because we already have all the cofactors. We have all the cofactors here. So we can take any of the cofactors, multiply it with the element, and we get the determinant. We have the adjoint. Now the second part to find the inverse is that we need is the determinant. So let's use the first row. Let's use this one to find the determinant. We know that the mod formula, because we have the cofactors, so we can use it directly. A11 into A11 plus A12 into A12 plus A13 into A13. Now be careful, don't do the mistake. These are cofactors. Yeah, this is the values of A11, this is A11, this is A12, and this is A13. The values for the matrix will be coming from here. This is the row 1 0 and 2. So this is A11, this is A12, and this is A13. Right, this is just want to clarify. It's not a big issue, but still there are mistakes of students. So we have 1 into A11 is 3, so we will put here 3 plus A12, we had 0. Here we say it is 0, so 0 times 1, and plus the third value is 2 into minus 2, the cofactor, so we have 3 plus 0 minus 4, so answer is minus 1. This is our mod. Now we have the adjoint, we have the mod, so what will be the inverse? A inverse is adjoint of A over A mod. So this is the adjoint, we divided by A mod, it's minus, so we got the final answer of A inverse. What's the final answer? Just change the sign of all. It was anything divided by 1 will be the same thing, just the sign will change. So we have minus 3 2 4 minus 1 1 1 2 minus 1 and minus 2. This is the inverse. This is the method you can use to find the inverse and adjoint of a square matrix of order 3 or more than 3. Like if the order is n is greater than 4, then it's going to be a little more addition. You have the fourth column and the fourth row, so you have to find 12 cofactors. Then you have to find the determinant and you can solve the question. It's going to take some time. So this is the method which can be used to solve adjoint and inverse of a square matrix of order 3 or more than 3. Thank you so much. I hope you understood it. Thank you so much for your time. See you next time. Take care.